Thank you, Jianliang. You have given us a very wonderful and by inspiring speech. I think your work is a very a good example of the interdisciplinary segment. So you have your works that have focus on cover the materials and the biomedical engineering and some biomedicine. So it's very good work. So now I think that Professor Ohami will give us the start question. Okay, and okay.
Yes. First of all, thank you very much, Professor Chen, for the valuable information and high-tech, challenging, actually, two very important topic of using hybrid material in chronic wound healing and actually fighting against cancer, which one of the very common in deaths in not only in Africa but in Europe and everywhere. I have few questions about wound healing and cancer as well. I just try to put things together about wound healing, using really a very interesting type of hybrid material of wound healing. You tackled for you starting with antibacterial. Of course, antibacterial is one of the most harsh to fight against. Your hybrid material was gram positive or gram negative or both of them?
Thank you for your question and the encouragement, Dr. Fahmy. Actually, this is a very important question. When the industry or scientists, they focus on to design the antibiotics, of course, lots of guys or lots of industry in developer like the broader spectrum antibacterial antibiotics. So your question, how about our hybrid system could be kill the bacteria with different type like positive or negative, right? Actually, I didn't show many slides of our details. Actually, I will tell you that our hybrid system will evaluate in the positive or negative bacteria. Both of them, they can kill the bacteria very effectively because these are not this hybrid system are not dependent on the antibiotics. They can generation like the reactive oxygen space, or we can use the photocell therapy. They can kill the bacteria, both of the negative or positive bacteria.
That is very, very effective way to fight against bacteria. I saw you use MAXine, which is one of the very, what we call it, recent discovery in this field of biphasic inorganic, which is quite very interesting. How MAXine actually, or the role of MAXine to fight against bacteria? I mean, you mentioned enhanced nanoenzymes, but how this catalytic activities it work by using MAXine? This is really genius idea.
Yes, actually, this case is the first example because lots of guys they use a nano enzyme like other inorganic oxides nanomaterial to generation the reactive oxygen space, and we found that like this MAXine, the guys use this MAXine to reduce the reactive oxygen space in the energy or in other applications. Actually, I don't remember the detail. So our guys, our member in our team, they use this MAXine to study it because they can not sorry, I totally told wrong. Sorry, because lots of reports they use the MAXine to generation the reactive oxygen space to degrade some organic pollutions because the reactive oxygen space can successfully reduce or degradation, totally is degradation some organic pollutions in some energy research field. So we just move their reported work.
就给你整点家里以后，再上山了，你有你那啥呢？你
Sorry. Okay.
Janice.
Okay, I'm so sorry.
Cut off.
Yeah, actually, we use the idea from other research field. They use the vaccine to generate the reactive oxygen space to reduce or degradation some organic pollution because they can generate the reactive oxygen space. So we move this vaccine material to our biomedical application. Also, this vaccine, they have the near infrared in radiation. They can generate the reactive oxygen space here.
That's really a very good idea.
Actually, we just use other guys' idea. They use a different research field. Actually, the detailed mechanism. Your question is very wonderful and a very good question. Actually, we don't know the details. We just use these materials can generate the reactive oxygen space. So we use these materials modify with some organic materials like the PVP, PEG to improve the stability or disability. And then use
Importantly, you direct it in a very,
Yes.
very good way to help many people. That is really very good. I have also wondering about you tackle really one of the most harsh side effect inflammation of wound. You use hydrogel-based zinc bivalence glyceric acid self assembly. How is this actually? I mean, you use zinc cations. Correct me if I'm wrong. With acetate or with which kind of? You publish in Advanced Material 2022 about using hydrogel based in zinc. And this is zinc coated or zinc cation itself?
Okay, that's a very good question. As you well know that like the SOD enzyme, this is the natural compound is actually the coordination compound. Actually, in this case, the zinc self-sensible with the GA, like here, the glarize. Sorry, I pronunciation now. Anyway, this the first stage, the first micelle or first hydrogel self-sensible here, the zinc between the zinc is a coordination compound here.
Okay, that's great. Yes.
Okay, thanks so much.
Okay. Do we have a little bit more time to ask about cancer, or we still maybe another colleague? I have a lot of questions. It's a good chance to catch Professor Chen with deep knowledge in big problems. I think worldwide big problems, cancer and chronic wound healing. That is yeah.
Yeah, they are very normal right now because the percentage of the patient like the diabetes population about 11%. Yeah.
Okay. So, is there anybody else have some questions? Okay. So I have a short questions, Jianliang. So, in your research, you have used some the hybrid materials, for example, some the vaccine or some others inorganic nanomaterials. So maybe this material they have the diverse different I don't know, for the treatment they have different mechanism. Maybe
Yeah.
for the ROS and for other the photothermals. So how to distinguish the effects for the final the treatment in your case?
Sorry, I don't understand the final sentence.
I mean,
Yes.
so we can give example for the vaccines. So the Maxine maybe in your work you have shown the Maxine have some the ROS introduce some effects for the treatment, but also the Maxine also have very remarkable the photothermal effects.
Yes, correct.
Yes. So how to distinguish these two different mechanisms for the treatment for the cancer treatment?
Actually, this is very good question. Actually, when we use this hybrid system's property like the light, sonodynamic, or photocell therapy, when we choose this hybrid system, we need to think about some side effect. For example, when we design this hybrid system, like the Maxine hybrid system, actually, we also you said that such as materials, they also have has the ability like the photocell therapy. Actually, here we use if we increase the amount of the hybrid system under the near infrared under the near infrared radiation, we believe they can serve as a photocell therapy. Actually, if the temperature is much high, they will cause the damage to the tissue, to the side tissue. So actually, we here use a very lower temperature, like 42, about 42, less than the 45, especially in the cancer treatment. Cancer treatment, we use the photodynamic most of the case. But in this case, actually, we use a lower temperature or middle temperature just to enhance the nanoenzyme, like the chemodynamic and dynamic. Actually, we not combination the photocell therapy because I we right here just to show us is that enhanced. Not when don't use the photocell therapy, just use they can generation the heat about 42, I believe. Then like to enhance the sonodynamic or chemodynamic. Several years ago, about 10 years ago, in my postdoc period, we use some photocell therapy because lots of scientists they don't like the photocell therapy because they will damage the normal tissues.
Yes, yeah, sure. Okay, thank you.
I have few questions about cancer. I'm not sure if we still have time or not.
I have time. Okay, it's no problem.
Okay, that is really good. That's really good from your side. I like to ask about a very nice hybrid nano system you make it for BDL1 regulation. That is really genius about this is antibody. Uh, how you reprogramming it in this as a strategy for reactivated immunotherapy. I know you mentioned few, but I'm interested in IR68. It's a very nice one, and the other one which you also make it IR LND one. This is really very nice strategy. If you can comment on that, that will be great.
Yeah, thank you so much. Your question is talk about the antibody, right?
Yes, yes. Tackling BDL1.
Most of you are although you are a scientist focused on the nanomaterial biomaterial, you think about when the patient go to the hospital. Your idea is similar with the clinicians, because the patient, if treatment with clinical used drug like chemotherapy, like the doxil, cisplatin, or like the doxil and so on, and the radiotherapy, actually they will trigger the overexpress like the TGF beta PD-L1. Okay, what you said is correct. The clinicians, they will use the antibody, right, to downregulation the PD-1 and the PD-L1.
That's right.
Yes, that's very correct idea. But in our side, we think about that the clinical patients, if received lots of the antibody, The first question is that they need to pay lots of money, right? Because antibody is very expensive. For example, the CAR-T about 1.5 million, maybe 1.5 million. Of course, the Chinese IMB previously reported. Anyway, it's very important. It's very expensive. We need to think about in the patient side. They need to pay lots of money if treatment, lots of antibody side effects, sometimes no sensitive. So we design the every system, every hybrid system for the PD-L1, TGF-beta, and other case. We just hope to reduce when the tumor cell eat or uptake these nanomaterials, they can successfully downregulate the PD-L1 in the tumor cells. Then that's meaning the immunoresistance will be invoked because the T cell will kill the tumor cell. For example, like how to say that if overexpression the PD-L1, the T cell only 10, they can kill the tumor cells. If we downregulation the PD-L1, right now the tumor cell from, for example, 5 to reduce to 1, but keep the same number of the T cell, still keep 10. We believe 10 T cell will kill 1 tumor cell is more easy. We just want to downregulation the PD-L1 in the tumor cells or tumor tissue. And sometimes the PD-L1 just only can downregulation the PD-L1 on the surface. But PD-L1 also receive the chemotherapy or radiotherapy, they are overexpress the PD-L1 not only on the surface, also on the in the cytoplasma, mitochondria, and the other place. So we design some hybrid system for the in the patient side, not from the clinicians. They can use antibody, but we can use this hybrid system to reduce the tumor cell or tumor tissues overexpression the TGF-beta or PD-L1.
This is really genius idea. You really tackle it from the others. That is very good. That's really very good.
Thank you so much.
I'm not sure if I have time for the last question or not, if Professor Tsang allowed me.
It's okay. You're welcome.
Okay. The last one, I am really very amazed about using iridium photosynthesizer for enhancing the photodynamic therapy. This is really a very good one. But iridium actually is this kind of heavy metal also. And if we speak about it, it's not easy to deal with it, especially for photodynamic control in it. How you tackle this kind of intrinsic problems you mentioned? It works perfectly well. We'd like just to know more a little bit about it.
Yes, what you said is very is right. Actually, this project we cooperation with the Jianliang University. Actually, for the mental compounds, what you said, this is very normal issues. Sometimes both of the guys use the self-sensible to solve what you said the problem. Here we use the bacteria. This bacteria likes to go or like to stay in the harsh environment, as well as that the tumor microenvironment is lack of the oxygen. So they will go deliver this iridium compounds or photosynthesize by themselves here.
Yeah.
Yeah.
That's very good one. There are a lot of questions, but I don't think time it will allow. I may contact you later on to
We can
establish
discuss on
communication.
the email. Yeah.
That will be great.
Okay. Thanks so much for your big encouragement. Thank you.
Thank you for a kind invitation. Thank you very much.
Thank you, guys. Okay.
Okay, thank you. Thank you, everyone. So next, so the meeting is now. Janice,
How about Dr. Wang is still here?
so
Yes. Thank you all for the presentations and also for the wonderful discussions. And thanks for everyone once again for joining us today. We hope you found the sessions insightful and valuable, and hope to meet you all next time. Thank
Okay,
you.
thank you
Thank
for
you.
your
Bye. Have a nice day.